very much. My name is Louriel Vilarinho. I'm from Federal University of Uberlândia. Uberlândia is a city, 600,000, 700,000 people really in the middle of Brazil. We have a good group, a welding group. We now are 5 professors. We have more or less 30, 32 graduate students and a lot of undergraduate students. And we may deal with welding process. And the presentation today is about some systems that we have done for monitoring pipe welding. That's work we did for, we still ongoing work, but it started from the needs of Petrobras. Petrobras is a Brazilian oil company. So that's our goal today, to try to evaluate some systems of those. I'll just give a quick view of 3 of those systems. Carolina, she's going to tell us about particular one, a vision system, sorry. And so let's try to have a bigger picture here, how we try to control the welding. It's not a straight control, it's just a man-supervised control. The need for that is because definitely when you look for ISO 9001, if you look to the clause 752, it says, okay, welding is a special process. What that means, you can't assess the process only by looking the weld bit. Okay, we have good weld inspectors worldwide, but even though, someone can weld stainless steel with stainless steel and place carbon steel as the filler metal, of course, it's stupid, but someone can do that tricky, and no one will never know that. So we need to know about which material you are buying, how you are applying that, and finally the weld inspector goes there and approve or disapprove your welding according to the welding procedure and the performance qualification. So basically, yes, that's good for us. At the same time, it's good. Okay. At the same time, it's bad, but it's good because we need to develop strategies to monitor the welding process. It's bad because we have to do that on a daily basis. Okay, just saying, okay, welding is a special process, paint is a special process, soldering, it's good for us. We are in the welding community, so we have a lot of work to do. We save our jobs, okay? So that's important because development and improvement of equipment and means of process monitor are needed. On the industrial needs for auditorship, corrective auctions, and training personnel. We need to train our personnel, the guys that work with welding, basing on some data that we have on the welding process. Talking about quality in welding, you say ISO 3834, which is, let's say, the ISO 9000 for welding process. Okay, I don't go for all the needs for that standard, but that standard requires that we include monitoring documentation of welding process. Definitely, we need to register everything that happens during the process. Not only, let's say, electrical variables, but also we need the data sheet of the material, both base and filler materials, how our joint configuration, power source, setup, welding consumables, shielding gases, purging gases if needed, and electrical techniques, electrical variables themselves. We need to monitor voltage, current, travel speed. If we are doing weaving, oscillation. Oops, sorry. And of course, because we are doing some, let's say, monitor systems for companies, we need to follow some standards. In our case, we're going to use ISO 17662, because it gives us some direction how we monitor and which are the standard deviation we are allowed to come out within those measurements. Okay, we monitor different stuff. Voltage, current, travel speed, Y-feed speed. Let's see what we intend to monitor. Okay, of course, we are not the first ones. There are, if you go downstairs, if you look to the fair, we see a lot of commercial equipment and commercially available. So our idea is to give an option or try to place more things, more technology together. Okay, and for doing that, we choose wireless communication instead of cabling communication. Our idea is to be free from cabling, because definitely is the trend today. We cannot deny that. Even downstairs, we see some guys selling wireless foot pedals to change the current during TIG welding, or to switch on, switch off the welding arc by wirelessly. Okay, as I said, we have plenty of commercial equipment, not just you know, no merchandise. It's just took from on the internet. So basically, what I'm going to do is to place everything together: power sources, different devices. You can use a laptop, you can use your smartphone. That needs to be practical. You need to get in the field. You need to get to the shop and start recording and start to monitor your systems. Okay. By controlling systems, not truly control, we just seeing what happens, and the operator takes the decision. Let's do together now 3 systems we have developed: wireless signal monitoring, vision system-based joint tracking, and waveform synchronized weaving. Let's start with the first one: wireless signal monitoring. Okay, the idea here is perform a conventional monitor system. Okay, let's monitor voltage, current, and wire feed speed. But how we're going to do that? By without cabling, by using wireless system. Okay, we have let's say a voltage divider. We have a Hall effect system. Everything must be conventional. Only the technology to place everything together, that what we developed. That's just a voltage divider, Hall effect sensor, and a device to measure the wire feed speed. And based on that standard, ISO 17662, we select the range and the uncertainty for our system that's according to that standard. We need to follow a standard to develop the system. So plus minus 6 volts for voltage, so we can record open arc voltage. Current plus minus 500, because we developed that for MIG welding, gas metal arc welding. And wire feed speed, but we can use with TIG welding, no problem at all. Any, let's say, arc welding process. And wire feed speed between 22 plus minus meters per minute. Okay, I'm not discussing here all the electronics involved. They are on the paper. You can take a look. All the schematics of electronics you may find there. It's on the book of abstract of our conference. So everything for the voltage and the current monitoring, that's everything there. We build our own conditioners. That's what we have built. And for integration, we use some commercial boards for converting analogical to digital signals and for wireless communication. In our case, okay, we have a microcontroller unit. In our case, we chose a Wi-Fi connection. For let's say a lower sample rate, we may have chosen Bluetooth or a Zigbee protocol, but in order to have, let's say, a bigger perspective, more users to really employ the system, we chose Wi-Fi connection. Ordinary Wi-Fi, G or N, doesn't matter. So we built our system. It's just a prototype, but it's working. All the electronics. And the human interface machine, how it's communicate to the user is by a web page. Why a web page? Because you can use on your notebook, on your smartphone, so on. Okay, that's another view. So we need to compare with conventional systems. We sampling at a conventional sampling rate of 1.25 kilosamples per second. So we see our systems is you can even see the difference between our reference system, which is a pretty standard one from National Instruments. It's a worldwide company for data acquisition. So we barely see the difference. But those in, let's say here in lighter blue is a cabling system. In lighter blue is the reference system by cabling, and in darker blue is our system doing that wirelessly. Let's see if I can see the movie. Okay, you're not seeing. Let's see if I can change that.